Good morning, guys. It's Friday, the 29th of January, and this is your morning starter. Hit pause on the screen now to have a go at the questions. Pay special attention to your division question today, please. We're going to move on to the answers in 5, 4, 3, 2, and 1. Hit pause on the screen to give yourself a mark, a tick if you got it, and a dot if not. Okay, let's have a look at today's lesson focus. So today we're looking at equivalent fractions again, and we started looking at these yesterday. We know equivalent means a fraction that is equal. So two fractions that take up the same amount of space, they're worth the same. Yesterday we used fraction walls to help us. There's one here to help you today. There are also some bar models to help you with each of these questions. See if you can have a go and work out which fraction is going to be equivalent to the fraction you've been given. So 5/6 is the same as how many 12ths? This bar's been split into sixths. Could you split this bar into 12ths? What would you do? Have a go. Hit pause on your screen now, and I'm going to move on to the answers in 5, 4, 3, 2, and 1. So looking at question 1, we're looking at 5/6, and we can see they're shaded on this top bar. To turn sixths into 12ths, we just need to split them up again, and we can see now that 5/6 is equivalent to 10/12ths. For this question, question number 2, 9/12ths is the same as how many quarters? Well, this top side is split into 12 sections, the bottom side is split into quarters. If we put our 9/12ths on the ruler here, on the line here, we can see it's equal to 3/4. 1, 2, 3. And finally, how many ninths is equal to 2/3? Let's go to 2/3 on our fraction wall and go down until we find the ninths. There we are, and that's 1, 2, 3, 4, 5, 6. 6 ninths. There we are. But what do we do if we don't always have a representation to help us? Is there a pattern that we spotted yesterday? So here I've got 1/3, and I'm trying to find out how many sixths it would be equivalent to. I look at the denominator, the number at the bottom, the number of parts my fraction is split into. I know that 3 and 6 are related. I know that 3 times 2 is 6. So if I take my thirds and I split them in 2 down the middle, so I split this one into 2 parts, this one into 2 parts, I get 6 parts. And I can see here that these 2 parts are shaded. So 1/3 is the same as 2/6. There they are side by side. Let's have a look at this one. 2/3 is the same as how many ninths? How would you turn these into ninths? What could you do? Hopefully you've stopped and had a think about this yourself. I'm going to have a go too. So one of the ways we could do this is we can see what the relationship is between 3 and 9. And I know to make 3 into 9, you times it by 3. So I think I should try and split each of these sections into 3 sections. So let's split this first section into 3. There we go. 1, 2, 3. They're not quite equal because my drawing tool's a bit rubbish. They should be equal to be a fraction. Let's see. So this is much, much more even. So I've split each section, each of those thirds, into 3 more parts. And now I have a ninths. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's really easy to see now that 2/3 is equivalent to 6 ninths. I could have split it going this way. I've still split each part into 3. It's just 3 going down rather than 3 going side by side to give me 9 altogether. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see it's still 6 ninths, 6 ninths. We've got lots of different representations here that we could use, and we're trying to find a fraction that's the same as, equivalent to, 4/5. I'd like you to hit pause, have a look at these representations. How will you find 4/5 equivalent in tenths? How will you find how many tenths there are? Let's have a look together. So if we're looking at the bar model first, I've shaded in my 4/5. I know that there are 2 5s in 10, so I'm going to split each of these into 2. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I can see my equivalent fraction here, 1, 2, 3, 4, 5, 6, 7, 8, 8/10. Easy peasy. If I look at the circle that I've been given here, again, I could just split each piece in 2, because 5 times 2 is 10. There we are, I've split each piece into 2, and again, if I count them up, I see I get 8/10. On the ruler here, I've got my 5ths at the top, and you can see the 10ths here have been split down the middle. They've been split into 2 again, because 5 times 2 is 10. And we can see 8/10 is the equivalent fraction. If we look at our fraction wall, we go to our 4/5, we go all the way down to tenths, and there we see 8/10 again. 4/5 is equal to 8/10. But what if we didn't have any representations? Could we have still worked that out? What do we notice about this equivalent fraction? I've already talked to you about 5 times 2 is 10. Is there a pattern up here? Let's have a think together. So, to turn 4 into 8, you would times it by 2 as well. Just the same as we did to the denominator. So the numerator has been multiplied by 2, and the denominator has been multiplied by 2, and here we have our equivalent fraction. Let's see if that pattern works with the other answers that we found. So earlier we found that 1/3 was the same as 2/6. Well, to turn 1 into 2, we times it by 2. To turn 3 into 6, we times it by 2 as well. It's the same as on the top as it is on the bottom. Let's look here. So earlier we found that 2/3 was the same as 6/9. Well, to turn 2 into 6, do I times it by 2? No, that would be 4. But 2 times 3 is 6. And 3 times 3 is 9. Again, it's the same on the top as it is on the bottom. So here I have a new fraction, 3/4, and I want to find how many 8ths there are. Let's have a look at what's happening on the bottom. How many 4s are there in 8? What am I going to do on the top? Pause and tell me what you think. Terry the turtle is here and he has an idea about what we should do. Terry thinks the answer is going to be 7. Because Terry says to turn 4 into 8, you add 4. So we do the same on top, we add 4, and that's how we get 7. Do you think Tiny Terry is correct? Pause the video and have a think. So here's Tiny Terry's answer again. He thinks we do the same on the top as we do on the bottom, and we have to add 4. But let's look at the fractions. Here are 3/4, and here are 7/8. Are they the same? Hopefully you can see that they aren't. So Tiny Terry has definitely got this wrong. But how has he got it wrong? We can see that actually 3/4 is the same as 6/8, not 7/8. Tiny Terry has got it wrong because we're not adding. When we're finding equivalent fractions, we're multiplying. To turn 4 into 8, we multiply it by 2. So we multiply the numerator by 2 as well. And if we look at all of the examples that we did back here, we timesed by 2, we timesed by 3. Let's just move forward again. Here are some fractions for you to have a go at. Have a look. What is your denominator being multiplied by? And whatever it's being multiplied by, do the same on top. Here, look at what your numerator has been multiplied by. And whatever it's been multiplied, do the same on the bottom. Hit pause and have a go. I'm going to share the answers with you in 3, 2, and 1. So, for this one here, we've got 3/4 into something 16ths. To turn 4 into 16, you times it by 4. So I know I need to times my numerator 3 by 4, and that will give me 12. For this one, I don't have my denominator, but I do have my numerator. To turn 2 into 6, you multiply it by 3. So I need to multiply 9 by 3, And 9 times 3, 9, 18, 27. Down here, to turn 7 into 14, I multiply by 2. Whatever I do on the top, I do on the bottom as well. Now, I'm missing it on this side, so I know that 14 divided by 2 is 7, so 20 divided by 2 is going to be 10. 7 times 2 is 14, 10 times 2 is 20. It works both ways. Now we've got 3/7. But I don't have any answer over here. So there are lots of answers that this could have had. We could have times both by 2 and had 6/14. We could have timesed it by 12 and had 36/8/4. We could have timesed it by 100 and have had 300/700. But so long as we've timesed it by the same on the top as we have on the bottom, we'll get a correct equivalent fraction. Here is another set of equivalent fractions, and they're all linked together in a chain. 3 over something is the same as something out of 20 is the same as 9 out of something is the same as 6/8. To fill in the gaps here, we're going to start with our 6/8 and work backwards. Let's have a think. How would you solve this question? The first thing that stands out to me is that 6 and 9 aren't in the same times table. I'm not sure how to work this one out. So I'm going to look at a number that is connected to 6. I'm going to look at 6 and 3. I know that 6 divided by 2 is 3 because 3 times 2 is 6. So this answer must be the same. I need to divide 8 by 2. 8 divided by 2 is 4, and now I have 3/4. Let's see if I can use that to help me with these middle ones. 4 goes into 20 5 times. 4 times 5 is 20. What we do on the bottom, we do on the top. 3 times 5 is 15. Let's have a look over here. Now 15 and 9 aren't in the same times table. We're not sure what to do with 20, so let's keep using our 3/4 to help us because they're all equal. We could use any of them. I know that 3 times 3 makes 9. What I do on the top, I do on the bottom. 4 times 3 is going to give me 12. And I've managed to fill in all of my equivalent fractions here. You're going to have a go now at some equivalent fractions. I know some of us found this a little bit tricky yesterday, so remember to use a fraction wall to help you if you get stuck. I have put some on Teams on the quiz for you to use, but you can always use one at home if you want to print one out as well. If you're still feeling stuck after you've checked the video and you've checked your questions, don't be afraid to ask for help in the Ask the Teachers channel. I promise you we're not as scary as we seem, and we'd love to help you with some maths problems. Enjoy, and we'll see you soon. Bye.